Good morning. So let us start a new number system known as complex numbers. So we have learned about real numbers, yes, such as natural numbers, whole numbers, integers, fractions, rationals, irrationals. All these numbers are the subsets of set of real numbers. So these all years you have learned in mathematics about real numbers. Now we are going to introduce a new set of numbers known as imaginary numbers. Imaginary numbers. Let's see what are imaginary numbers. If we consider the numbers like root -1, root -2, root -3, root -4, etc. So here we are taking the root as even root like square root, fourth root, sixth root, eighth root, etc. So if we consider this kind of numbers, we cannot find out its real value. If you type this in your calculator, you get a math error. In our normal form of calculator, if you type it, we get a math error, because as it has no real value, our normal calculator cannot find out its value. Instead of that, if you convert your calculator into complex form and type square root of -1, you find its answer as I. You type square root of -2 in your calculator in complex form, mode should be complex, then you get its answer as root 2i. Square root of -3 as root 3i. Square root of -4 as 2i, etc. That means, though the calculator gives us these values, we cannot find the actual value of any of these numbers. Such kind of numbers are called as imaginary numbers. Okay. The smallest imaginary number is root of -1 and it is represented with I. So we can say I squared is -1. I squared stands for root -1 square. Square and square root get cancelled, remaining it is -1. So I is square root of -1 and I squared is -1 itself. Okay. So when we think about imaginary numbers, we need to have a very few example questions to be in touch with imaginary numbers. You may find this kind of questions right in simplest form. Like suppose we have a question square root of -144. Write it in the simplest form. That means this is not in the imaginary form now. We have to write it into the imaginary form. Just if you type this one in your calculator, you get the answer. But if the question is without calculator, so when you get a number like this, see, we can factorize -144 as -1 into 144. So -144 is -1 into 144. So it can be expressed as square root of -1 into square root of 144. And root of -1 is I into root of 144 is 12. So we get I into 12, or can write it as 12I as the simple form. Okay. Square root of minus 18 can be written as root of minus 1 into 18. So I'm writing 18 as 9 into 2. So we get it as root of minus 1 into root of 9 into root of 2. That's equal to root of minus 1 is I into root of 9 is 3 into root 2 remains as root 2 when we are doing manually. So we get this answer as 3 root 2 into I. So 3 root 2 into I. So to avoid confusion, let's put 3 root 2 in bracket. Okay. Square root of 9I plus 16I, the whole divided by 4I. So like any other number system, here also you can go on our normal calculation. You can do our normal calculation. Like you see, 9I plus 16I, both are like terms, they can be added. So we get it as 25I divided by 4I. So when you check the numerator and denominator, both have a common factor I. Yes, can get cancelled. So what is remaining? Root of 25 divided by 4, which is equal to 5 by 2 as answer. Another commanding word you find from this topic is solve. Solve x squared plus 1 is equal to 0. Okay, so here solution is x squared is minus 1. So x is square root of minus 1. You know square root of minus 1 is I. So we get the value of x as I. Now at present we have two set of numbers with us. One is set of real numbers, and the other one is set of imaginary numbers. Set of real numbers and set of imaginary numbers. And you know real numbers consist of all the type of numbers such as natural numbers, whole numbers, integers, rationals, irrationals, fractions, decimals, etc. And imaginary numbers consist of root of negative numbers in the form of I. Okay, so if you combine these two numbers together, that means the union of real numbers and imaginary numbers. The union of real numbers and imaginary numbers forms a new number system that is known as complex numbers. Set of complex numbers. And we can call set of complex numbers as the universal set for all the numbers, because any other number is derived from complex numbers. So when we consider complex numbers, it is the combination of a real number and imaginary number. If we consider a real number A and an imaginary number IB, if the real number is A and the imaginary number is IB, then A plus IB can be called as a complex number Z, or A minus IB can be called as a complex number Z. So if A is a real number and IB is an imaginary number, then A plus or minus IB can be considered as a complex number. And the form of a complex number is x plus or minus iy. Okay. And here x is the real part of z. We'll write it as rez, real part of z. And y is the imaginary part of z. X is the real part of z and y is the imaginary part of z. Sometimes in rare cases iy will be considered as the imaginary part of z. Okay, let us solve a question. 5z square plus 14z plus 13 is equal to 0. So whether it is z, x or y, whatever, we have a quadratic equation here. So we can use the same quadratic formula. So our question is 5z square plus 14z plus 13 is equal to 0. So here a is 5, b is 14 and c is 13. And you know, as per quadratic formula, z is minus b plus or minus square root of b squared minus 4ac by 2a, which is minus 14 plus or minus square root of 14 squared minus 4 times 5 times 13 divided by 2 times 5, which is 10. So when you go on with simplification, we get the answer as minus 7 by 5 plus 4i by 5, or minus 7 by 5 minus 4i by 5. So we get two solutions, and you can see each solution, it looks like x plus iy. This is x minus iy, where x is minus 7 by 5 and y is 4 by 5. So this is one of the important concepts you have to remember. When you find the solution of a quadratic equation, when you find the solutions are also known as roots. You may find the term root in this, root. So here the roots are minus 7 by 5 plus 4 by 5i, or minus 7 by 5 minus 4 by 5i. They are the roots or solutions. See, when you find the solutions of quadratic equations from complex numbers, once we know one root, the next one we can predict easily. It's very simple. If one root is x plus iy, if one root is x plus iy, then the other root will be x minus iy. If one solution is x plus iy, let's use it as alpha. Then the other solution will be x minus iy, which is beta. Okay, if we just go through another one question, we can come to know this easily. So consider a quadratic equation with the complex variable z. A is z squared plus b is z plus c is equal to 0. Then it has two roots, which are alpha and beta, in which if alpha is x plus iy, then beta is x minus iy, and x minus iy is known as the conjugate of x plus iy. Now what do you mean by conjugate? It's nothing but x minus iy is the conjugate of x plus iy because its product. If you take the product of both of these, if you multiply a number and its conjugate, we get a real number. We get a real number. Like if you multiply this one, it's like x squared minus iy the whole square. That's equal to x squared minus I squared y squared. That is x squared minus, I squared is minus 1 y squared. So we get it as x squared plus y squared. See, it is a real number because it has no I. So the product of two complex numbers, if the product of two complex numbers is a real number, just recall once again, if the product of two complex numbers is a real number, then each complex number is the conjugate of the other. Suppose z1 and z2 are two complex numbers. The product of these two complex numbers is a real number. Then we can say z2 as a conjugate of z1, or z1 is a conjugate of z2. Got what do you mean by conjugate? And if z is a complex number, its conjugate is denoted with z star. That means if z is a plus ib, then its conjugate is z star, which is a minus ib. So that the product of z and z star is a real number. Okay. And another thing what you need to remember is, when we consider a number, it is just a one-dimensional number. But when we consider, because suppose you are considering a number 2, a number 2 is on number line. It is on number line. A number is number 2. That means it is one-dimensional. But when we consider complex number, it is a two-dimensional number. Like if you make x-axis as a real part of z and y-axis as imaginary part, then if you mark a number here, that number represents a complex number. So here x-axis represents set of real numbers like 0, 1, 2, 3, 4, 5, etc. And y-axis represents set of imaginary numbers like root of minus 1, like 1i, 2i, 3i, 4i, 5i, etc. Okay, then a number or a point in any one of the quadrants gives a complex number. So a complex number has x-axis and y-axis. That means every complex number is two-dimensional number. Okay, we'll learn about how to mark it in the coming topic, the topic Argand diagrams. So we have a question here. 2x plus 5 plus I of y minus 5 is equal to 0. Find the value of x and the value of y. So here our question is, the given part 2x plus 5 plus I of y minus 5 is equal to 0. Now we need to find the value of x and y. So to find the value of x and y, we need to do the comparison of left hand side and right hand side. That's the only option we have. So try to make the right hand side also in the form of a complex number. As if like we can write 0 as 0 plus 0i. 0 can be written as 0 plus 0i. So now just compare real part and imaginary part. So when you compare real part, here the real part is 2x plus 5 and here the real part is 0. So we can say 2x plus 5 equal to 0. Because if two complex numbers are equal, then their real parts are equal and imaginary parts are also equal. It is a is equal to x and b is equal to y. Okay, so when we use that concept here, we get 2x plus 5 is equal to 0 and y minus 5 is equal to 0. That is, we get x is equal to minus 5 by 2 and y is equal to 5 as result. Another question, find the complex number z satisfying the equation z plus 4 is equal to 3i z star. Z star is the conjugate of z. So we have to find the complex number z. So for this question we cannot use z directly. So we have to assume a complex number for z. Like z can be assumed as x plus iy. Let's assume z as x plus iy. Then what will be z star conjugate of z? It will be x minus iy. So we get z plus 4, that is x plus iy plus 4 is equal to 3i into x minus iy. That is x plus 4 plus iy is equal to, when you multiply inside, what do we get here? 3i into x, that is 3xi minus 3i into iy, that is 3yi squared. I into I is I squared. So we get x plus 4 plus iy is equal to 3xi. What is the value of I squared? You know I squared is minus 1. So minus 3y into minus 1 is plus 3y. Isn't it? That is x plus 4 plus iy is equal to 3y plus 3xi. See, it's a complex number with the real part is x plus 4 and imaginary part is iy. It's a complex number with the real part is 3y and imaginary part is 3xi. Okay, and these two complex numbers are equal. So we can say x plus 4 is equal to, x plus 4 is the real part, that is equal to the real part 3y, and y is equal to 3x, imaginary part. Okay, now with the help of this one we have to do the calculation. Like, how do we find? We can use elimination method or substitution method, but substitution is better here. You know x plus 4 is 3y. But you know that this y is 3x. So we get x plus 4 is 3 into y is 3x. So we get x plus 4 is 9x. If you take x to that side, we get 4 is equal to 8x. 9 minus 1. Or x is equal to 4 divided by 8, which is equal to 1 by 2 as the value of x. Once you know the value of x, it is easy for us to find the value of y. This y is equal to 3x, which is 3 into 1 by 2. That's equal to 3 by 2. Therefore, z is, as per our assumption, z is x plus iy, which is 1 by 2 plus 3 by 2 I as answer. In the next class, we'll discuss about the operation of complex numbers, the complex plane, and the Argand diagrams. Thank you.